So now we have an example of dividing by complex numbers, and the problem is 8 minus 3i divided by negative 2 plus 5i. Now there is a strategy that we use to multiply complex numbers, okay, and to divide complex numbers, and that is to multiply both the top and the bottom of our fraction by the complex conjugate of the denominator. Okay, so the denominator in this case is the bottom one. So the denominator here is minus 2 plus 5i. And the conjugate of that, to get the complex conjugate, we change the sign of either the real part or the imaginary part. So the conjugate of this, which is called, I suppose strictly speaking, it's called the complex conjugate, is going to be either 2 plus 5i or minus 2 minus 5i. So you can change whichever one of those you want to. It's most common to change the sign of the imaginary part. Okay? You don't have to do it that way, but that's probably the way it's done most often. So, we now go back to our problem. 8 minus 3i over minus 2 plus 5i. And we're going to multiply, and get the pen to work again, we're going to multiply this by the complex conjugate of the bottom. So minus 2 minus 5i over minus 2 minus 5i. Okay, so let's work out the top and the bottom separately, and we can sort of move over to the side a little bit to work these out. So the top is going to be 8 minus 3i by minus 2 minus 5i. And we'll just use FOIL to do this. So I'm going to go through this a little bit quickly, but all we're doing is using FOIL. So 8 by minus 2 is minus 16. 8 by minus 5i is minus 40i. Minus 3i by minus 2. Minus by minus is plus. 3 by 2 is 6i. And minus 3i by minus 5i. Minus by minus is plus. 3 by 5 is 15i squared. So that's going to be minus 16. For the I parts here in the middle, it's negative 40 plus 6, that's negative 34i. And the I squared, remember, we're going to replace that with negative 1. So that's going to give you negative 16 minus 34i minus 15. And if we simplify the number parts of this, the real parts with negative 16 and negative 15 is negative 31 minus 34i. Okay, so that's what the top turns out to be, negative 31 minus 34i. Now, you might think, how is this making life any easier for us? The numbers have got bigger and more out of control, but we're going to fix that now in a second. So, there's nothing like clashing orange and purple and green. So we'll go now to fix the bottom. And let's see what happens. On the bottom, we're going to multiply negative 2 plus 5i. And this is what we're talking about here. Okay. Okay, that's what we're talking about. We've already done the top. But it's going to be negative 2 plus 5i by negative 2 minus 5i. I'm just going to move this over a little bit so that I have more room. So again, use FOIL. So negative 2 by negative 2, minus by minus is plus, 2 by 2 is 4. Minus 2 by minus 5i, minus by minus is plus, 2 by 5 is 10i, plus 5i by minus 2, plus by minus is minus, 5 by 2 is 10i, and then plus 5i by minus 5i, plus by minus is minus, 5 by 5 is 25, I by I is I squared. Now, the plus 10i and the minus 10i, they will go away, and that is always what happens when you multiply a complex number by its own conjugate. Whenever you multiply a complex number by its own conjugate, the I part goes away. And what you're left with is 4 minus 25. Now, I squared, remember, replace I squared with minus 1. So that's going to be 4. Minus 25 by minus 1 is plus 25. And 4 plus 25 is 29. So the bottom of this is, I don't know why I made that a wavy line. It shouldn't be. It's just a regular fraction. Is 29. Okay. Now what we've done here is we have got rid of the imaginary part on the bottom. Okay, we now just have a real number on the bottom. And very often what people will do to finish off because it can be useful, is they will just split this up and write it as negative 31 over 29 minus 34 over 29i. And if you do that, the important part is to keep the bottom under both the real part and the imaginary part. The bottom belongs to both the real part and the imaginary part. So there is our final answer. Okay, so a lot of careful algebra and multiplication required, but certainly a doable problem. Okay, thanks for watching.